Welcome back to Boson Buzz. I'm Monty Molecule. Far north, beneath the silent tundra and boreal forests, lies one of the planet's most important and most vulnerable vaults, permafrost. This is ground that has been frozen solid for thousands of years, a deep freezer locking away ancient plant matter and, crucially, vast amounts of greenhouse gases like methane and carbon dioxide. But as the Arctic warms at an alarming rate, far faster than the rest of the world, this freezer is beginning to defrost at its edges and in its depths. The threat isn't just to the landscape of slumping hills and disappearing lakes, it's a potential global tipping point. If too much permafrost thaws, it could release immense stores of gases that accelerate global warming in a dangerous, self-feeding loop. The question is urgent. Can we monitor this vast, remote, and frozen landscape well enough to understand the threat in real time? And more importantly, can we find ways to help stabilize it, to become stewards of this icy realm? This is the story of the Permafrost Guardian, a growing suite of technologies from space, sky, and ground acting as the early warning system and potential first responders for the roof of our world. The scale of the challenge is almost unimaginable. Permafrost isn't just a thin layer of ice, it's a deep, complex geology that underlies about a quarter of the northern hemisphere's land. It's remote, harsh, and the most critical changes, the silent thawing tens of meters below, are invisible to the naked eye and to ordinary satellites. For decades, studying it was a heroic but scattered effort. Scientists would drill cores by hand, taking frozen soil samples that were like snapshots from a single pixel of a giant changing picture. We knew the colossal freezer door was creaking open, but we were deaf to its alarms and blind to where the hinges were bending or the seal was breaking first. To protect this system, we first needed to give it a voice, a nervous system, and a detailed living health chart. This new awareness begins with a constellation of eyes in the sky, armed with more than just cameras. A new generation of radar satellites uses a technique called InSAR. They send down microwave pulses and measure the echo that bounces back. By doing this repeatedly over the same spot, they can detect minuscule changes in the ground's elevation, a sinking of just centimeters, which is a clear sign of subsidence as the ice wedges within the permafrost melt and the soil collapses into the voids. Other satellites carry thermal sensors that map surface temperature changes with extreme precision, and hyperspectral sensors that detect the greening of the tundra as shrubs and trees move north. This greening is a double-edged signal. It shows life adapting, but darker vegetation absorbs more of the sun's heat, accelerating the thaw underneath, a process we can now track from orbit. But satellites can't smell the most telling sign of trouble: the gas. That's where a brave new network of ground-based sentinels comes in. Scientists are deploying rugged, autonomous sensor stations across the Arctic, from Siberia to Alaska to Canada. These stations are like intensive care monitors for the soil. They have long probes that measure temperature at multiple depths, from the surface down to where the eternal frost should be. They have automated chambers that close over patches of ground or water, sniffing the air inside every hour for spikes of methane and CO2, the telltale breath of the thawing Earth. Some are even equipped with hydrophones lowered into thermokarst lakes, listening for the fizz and pop of methane bubbles, like a stethoscope on a restless patient. All this torrent of data, the elevation changes from space, the temperature profiles, the gas readings from the ground, flows into powerful supercomputer models. These models fuse the information to create a living, breathing digital twin of the Arctic permafrost. This isn't a static map. It's a simulation that can run forward in time, allowing scientists to identify hotspots and predict cascading failures. They can see which areas are thawing most rapidly, which slopes are becoming unstable and threatening the villages built upon them, and where the largest plumes of methane might emerge. This predictive power is the first, crucial step of the Guardian. It transforms a vague, massive threat into a map of specific, manageable risks. It tells us not just that there's a problem, but exactly where to look and where to act first. But monitoring, no matter how precise, is only half the battle. The exciting frontier of the Permafrost Guardian is moving from diagnosis to supportive therapy, exploring ways to actively help the land stay cold or even heal itself. One of the most elegant approaches is inspired by the land's original inhabitants, large herds of grazing animals. Scientists are studying the impact of animals like reindeer, musk oxen, and even reintroduced bison. In winter, these animals' hooves trample down the deep, insulating snow cover. Untouched, fluffy snow acts like a thick down comforter over the frozen ground, trapping the Earth's heat. Trampled snow is dense and compact, a far poorer insulator. By removing this blanket, the bitter -40-degree Arctic air can penetrate deeper into the soil, helping to refreeze and stabilize the permafrost below. It's a form of natural climate engineering, using animals as four-legged landscape managers to turn back the clock, one winter at a time. For more immediate localized threats, like a thawing riverbank threatening a community's freshwater source or a critical pipeline or road built on now unstable ground, more direct engineering solutions are being piloted. One ingenious idea involves thermosiphons, simple, passive, hollow metal tubes driven deep into the ground. They contain a refrigerant. In winter, the refrigerant vaporizes at the relatively warmer bottom of the tube in the thawing ground, rises, condenses at the frigid top exposed to the air, releasing its heat into the atmosphere, and then trickles back down as a liquid. This continuous energy-free cycle actively pumps heat out of the ground, acting like a refrigerator coil for the soil. A field of these tubes can refreeze the ground around them, creating stable, frozen pillars that anchor the landscape. The overarching vision of the Permafrost Guardian is not about conquering or geoengineering the Arctic on a massive scale. It's about providing intelligent, assistive care to a profoundly important and struggling natural system. It represents a fundamental shift from seeing the Arctic as a passive, distant victim of climate change to viewing it as an active patient we can now diagnose, monitor, and support with precision. By listening to the whispers of the soil, the sighs of escaping gases, and the groans of shifting land, we can understand the pace and pattern of change like never before. And by working with natural processes, from animal migrations to the basic laws of thermodynamics, we might just buy the crucial decades needed for global efforts to slash emissions to take full effect. The Permafrost Guardian stands watch, not with a dramatic weapon, but with a global stethoscope, a predictive brain, and a clever, gentle set of tools, working tirelessly to keep Earth's ancient carbon safely on ice. From silent, frozen vaults to a networked, speaking landscape monitored from orbit and soil. That's the vigilant, ingenious promise of the Permafrost Guardian. It's a fusion of satellite intelligence, ground truth sensors, and humble, clever interventions aimed at stabilizing one of our planet's most critical and overlooked biomes. It's a future where we use our greatest tools, relentless observation, deep understanding, and respectful engineering to protect a natural system that, in turn, protects the climate stability of us all. If the idea of safeguarding our planet's icy carbon vault with technology and wisdom fills you with hope, please help Boson Buzz monitor the horizon. Give this video a like and subscribe for more stories of planetary stewardship. I'm Monty Molecule. Until next time, have a safe and curious week.